Welcome to this explainer. Today, we're going to demystify a tool that sounds kind of silly, but is actually a highly rigorous Lean Six Sigma method for optimizing your physical workspace. Seriously, if you've ever felt like your daily workflow is more of a physical workout than, actually getting things done, you are in the exact right place. We're talking about the spaghetti diagram.
I want you to consider for a moment the silent, completely invisible villain of productivity, motion waste. It just quietly eats up your time, literally, one short walk at a time. Think about it. It's those extra steps to the printer, right? Or the trek all the way across the warehouse for a tool that really should just be right at your bench. Or even just zigzagging through an office to get a single signature. It accumulates so silently that most of the time, we don't even register it as a problem.
So here's our roadmap for today. First, we're exposing invisible motion waste. Second, what actually is a spaghetti diagram? Third, creating your own diagram. Fourth, turning those drawings into hard data. And finally, finding waste way beyond just motion. Let's dive in. All right, Section 1, Exposing Invisible Motion Waste, the Hidden Cost of Layout.
Our journey starts by confronting a pretty frustrating reality. Poor physical layouts dictate our efficiency way more than we realize. So often, workspaces just grow organically. A new cabinet gets shoved wherever it fits. A new role is added without anyone actually redesigning the walk pattern around it. And the result? A hidden tax on literally every single cycle of work you perform. Which brings us to our core definition. A spaghetti diagram is essentially a visual map that traces the actual physical movement of a person, a part, or a document as it travels through a process. When you trace every single trip over a set observation period, the resulting tangle of overlapping lines looks exactly like, a messy plate of spaghetti. And that perfectly executed, messy plate of pasta, that's actually a feature, not a bug, because it makes all that invisible waste absolutely undeniable to anyone looking at it.
And this brilliantly illustrates why we simply cannot just rely on standard process flowcharts. Think about it. Two process maps can look completely identical on paper, outlining the exact same logical steps, but only a physical mapping reveals that one layout requires 40 feet of walking per cycle, while the other takes a staggering 400 feet. 400! That is a massive, massive difference in efficiency and worker fatigue that a standard flowchart simply is not going to show you.
Moving right along to Section 2, what is a spaghetti diagram? Origins and precise use cases.
Okay, so it's super important to know exactly when to pull this specific tool out of your process improvement toolkit to save your team time and energy. There's a really clear delineation here. If your goal is to understand physical travel distance and layout bottlenecks, the spaghetti diagram is absolutely your go-to. On the flip side, if you're tracking logical sequences and lead times, then you'd use a value stream map. They answer fundamentally different questions.
Tracing its intellectual roots really proves that this is a time-tested, rigorous methodology. It actually dates all the way back to the early 1900s, with Frank and Lillian Gilbreth's pioneering motion studies, and their Thorblegs, which is just a fancy word for a taxonomy of elemental body motions. Fast forward a bit to the mid-20th century, and it was formalized and popularized by the Toyota production system as the standard way to expose waste during Kaizen events. And today, wow, it has spread way beyond manufacturing floors. You'll find it optimizing nurse travel paths in hospitals, streamlining document flow in administrative offices, and reorganizing massive distribution warehouses. It's everywhere.
Okay, Section 3, Creating your spaghetti diagram, observation, and notation.
Building a spaghetti diagram well is honestly a discipline. It's definitely not just some casual sketching exercise. It requires a really standardized approach to be truly effective. To make sure your diagram tells a clear story rather than just becoming a chaotic sketch, you must strictly follow these notation conventions. First off, always use a unique color for each person or part you're tracking. Second, number every single leg of the path in the actual sequence it occurred. Third, make sure you distinguish an operator's travel from material travel by using different line styles, like solid versus dash lines, for example. And finally, map out those rare exception paths differently so you don't accidentally overstate how often an unusual trip actually happens.
Now, the absolutely crucial point here is that you must document what actually happens on the floor, not what the standard work document says should happen, right? Start by defining a really narrow scope, like maybe just one operator for one representative cycle on an accurate scaled floor plan. Next up, you just observe and trace the real-time movement, number the paths, and calculate the totals. Once you've identified the waste patterns, sketch out a proposed redesign and implement it. And finally, you got to rediagram the space to validate that you actually, in fact, reduce the travel distance.
Moving to Section 4, turning drawings into hard data, the business case.
So, let's see how this builds from a messy, tangled drawing into undeniable quantitative data that leadership simply cannot ignore. Because sure, the picture is absolutely what gets attention in the room, but the numbers are what ultimately get a budget approved. By multiplying a single observation into annual totals, you create this incredibly powerful business case that can easily justify staffing changes or budget for a big redesign. You start by calculating the distance per cycle. Then, you multiply that by cycles per shift to get the daily burden. Finally, multiply that by shifts per year. Suddenly, that little bit of extra walking turns into literally miles and miles of wasted transit per operator per year. When you also calculate the percentage of cycle time spent just walking instead of actually adding value, the need for change becomes mathematically unarguable.
And our final section, Section 5, finding waste beyond motion, uncovering classic inefficiencies.
All right, now for the climactic payoff. The spaghetti diagram is definitely designed for motion, but if you look really closely, it actually acts as a diagnostic X-ray for so much more. A careful review of your map frequently surfaces evidence of several other classic lean wastes. Seeing super long paths carrying materials? Well, that indicates excessive transportation waste. Seeing repeated trips back and forth to a single staging location? That highly suggests heavy inventory buffering. What about a massive cluster of multiple paths converging on one single location? Yeah, that usually means people are just waiting in a queue for a shared resource. And backtracking paths? Those often point straight to an area for rework, exposing defects in the process. It's all right there on the map.
To summarize all of this, here's a core takeaway to keep in mind. A spaghetti diagram is the single fastest way to make invisible motion waste undeniable to everyone in the room. When it's executed correctly, this tool beautifully bridges the gap between those doing the actual work and those managing the budget, making the invisible totally visible. It gives new employees and seasoned veterans alike a shared, completely non-verbal way to just point to a diagram and say, "Look at this knot of lines. This layout is broken, and we need to fix it."
So, I leave you with this challenge. Grab a piece of paper today, sketch out a quick floor plan, and just observe your own daily environment. Track your movements for just 1 single hour. What bottlenecks will you discover? How much hidden motion waste can you expose and ultimately eliminate? Because the answers are right there in the layout, just waiting to be mapped. Thank you so much for joining me for this explainer, and happy mapping.